Okay, so in this problem we want a differential equation of the form dy dt equals ay plus b such that, let me get the right color there, okay, so as t goes to infinity, we want y to approach 2/3. So the way we do that, if we look at our gradient field here, we find 2/3. That's going to have a zero slope or zero gradient there. It's going to have positive slopes below 2/3, and it's going to have negative slopes above 2/3. That way, any solution will converge as t goes to infinity. So, with that said, the way that we can do this is some of our information says that when dy dt equals 0, that means that y is equal to 2/3. So we find what makes dy dt 0. So 0 equals ay plus b. That means y is equal to negative b over a, solving that equation. Now, we get to guess two values of b over a such that this is equal to 2. That should be a 3. Sorry. This is 2/3. Okay, so we pick any value of b and a such that negative b over a equals 2/3. So I'm going to pick b equals -2, a equals 3. So then our differential equation becomes dy dt equals 3y minus 2. Well, now we have to consider our gradient field, because when y is greater than 2/3, we want dy dt to be negative. Well, let's look at our equation here. If y is greater than 2/3, if y gets really big, that means our derivative is going to get also very positive. So we've guessed the wrong way. We need this to be negative. We need to negate it so that above the 2/3 mark we have negative values, and below the 2/3 mark we have positive values. So our solution then becomes dy dt equals -3y plus 2, or we could write that as 2 minus 3y. So that is a valid solution. There are other solutions, but that is a valid solution to problem 1.1.8. This is 1.1.8 of Boyce and DiPrima's elementary differential equations and boundary value problems.